G'day guys, welcome back to my channel. Exciting news today. I just recently got back from Sydney and where I attended the Autodesk University 2015 held at the Hilton Hotel. It was fantastic. I've come back, I'm fully psyched and I'm pumped. The biggest buzz up there at the moment, especially at the conference, was Fusion360, and it truly is a momentum. It is just growing and growing and growing in size. I got back anyway, and today I thought, well, why not? Let's do something else with Fusion360. So today I made this, a little two-piece sliding bevel, which was drawn in Fusion360, and all the cam, everything done and machined here in my home CNC machine. I'm going to share this file on the Fusion sharing portal, Fusion360 sharing portal, and you're welcome to use it and have a crack at it, guys. It is fantastic. Another thing, if you like my channel, please subscribe and follow me on Instagram on the same username, DCTTeacher1. Alright, let's get into it. Okay, I've got Fusion360 opened up here on my MacBook Pro. I'm going to go through the strategy that I use to draw and to do the cam tool pass on this model. First thing I did was to draw the blade, and it was just simply a sketch that was extruded, had some features applied to it and the slot put into it. A very basic, easy, first time model to draw when using Fusion360. The second part I drew was the stock. And the stock, once again, a simple sketch, extrusion, the hole features, and of course the fillets applied. The last thing I drew was the fixture plate. And the fixture plate was drawn, once again a simple sketch, extrusion, some holes. Then the parts were brought in, so the blade was brought in and the stock brought in and assembled. Let's have a look how I did that here. Okay, let's go and open up the CAM software now and take a look at the toolpath strategy that I used to create my project here today. Alrighty, I'll just regenerate that, even though they are generated. I'll just go through it to show you. Okay, let's click on simulation. And let's turn the stock option on here. Now I just did all the toolpaths under just one setup here, but you'll see in the video how I actually did it. I did this top plate first, and then I did the bottom plate, and then I brought the two together and continued. But I just kept it all under the one setup. It'll make sense as you watch the video. 6mm end mill bit to do the slot toolpath, 4mm end mill bit to do the boring cycle. The fixture plate was then put in, it was spot drilled, then come back and drilled with a 5mm drill bit. And then what I did was the adaptive clear it, so as to put the parts on the fixture plate, run a 6mm adaptive clearing toolpath strategy, 2D of course. I'll go to the next operation. And then it was the profile on the contour, cutting them all out. And last but not least was to come in with the spot mill and just take a deburring cycle, creating this little tiny chamfer on the top of the face. Okay, well, it's time to spin some mill bits and rip some chips, so let's go to the machine. Okay, we've finished our two-piece sliding bevel project, and it's really come out nice, and I'm quite happy with it. Not bad using Fusion360. You know, Fusion360 is free, don't forget, as long as you're a student, teacher or hobbyist. You can't use it for industry or business. Obtaining accurate angles is relatively easy. All you need to do this is a steel rule, a pair of spring dividers and a scriber. Now what I've done, I've got a sheet of aluminium here, and I've covered that with Dicam layout fluid to make it easier for you, the viewer, to see. What we first need to do is to scribe, using our spring dividers, a parallel line on the bottom of this plate. I'd set your spring dividers up roughly about 10 millimeters, and here we go. Scribe the line nice and neatly along the bottom. Okay, finding a simple point here, and we'll just mark this with a scratch, and we'll call this point A. We're going to set our spring dividers up now roughly to 50 millimeters. And put the one edge of the spring divider on point A and the other edge on the line. All you have to do now is scribe yourself a nice arc, come right around to about here. Now we've got point A, now we have point B, which is this point here. Not sure if you can see that. What you want to do now, using your spring dividers, don't adjust them, keep them on the 50 millimeter, is to put one leg on point B and mark a point of intersection on that arc that you just scribed previously. This now can be point C, and then we'll do it one more time, putting one leg on the corner of point C to get D. Alrighty, now using our steel rule, let's scribe a line through point A and the point of intersection on point C. So I put my scriber there, line up my steel rule, and here we go. That line that I've just scribed now is a perfect 60-degree angle. If I come over here to point D, point of intersection, set up my rule, one more time, scribe on the mark, so we now have 120 degrees. 120, this one is 60. Now we can obtain variations on these angles once we have these 2 points. To find a 90-degree angle, we just simply put our spring dividers on point D and scribe a line, a mark out here, an arc out there. Put the other end on point C, scribe your arc. Now, because we've bisected the 120 and 60-degree angle, this will give us 90 degrees. There's my 90-degree angle, and I'll write 90 up there. I'm not sure if you can see this on the camera. Okay, now we need to obtain the 30-degree angle. That's really simple. If we intersect the 60-degree at points C and B and bisect that angle, this will give us 30 degrees. I've left the spring divider set at 50 mil. There's my arc, my other arc, and here we go. There's my 30-degree angle. Okay, so you're probably wondering now, you're probably asking yourself, okay, well, how do we get 45 degrees? Well, that's quite simple. If we intersect the 90-degree, so we bisect that by picking up point B and this point here on the arc, that should give us 45 degrees. So let's step that off now. Just have to go a little bit further on that arc. Now, all this stuff I'm showing you guys is very old school. It's called geometric construction. And there we have it. So we've got quite a few angles now which we can use with our little two-piece sliding bevel. Okay, and we can set them up here, lock him off, and we can get quite accurate angles using this method. Okay, I hope you found this little job interesting. Even, if you want to, I'm happy to share this file with you through the Fusion360 sharing portal. Okay, thanks guys. See you next time.